Well, hello there, amazing people. I'm super excited to be here today with you where we get to treat another question from the archives. Okay, so today's question says lead is found in the ore called Galena, which contains lead sulfide. Okay, so here is the formula for lead sulfide, PbS. Before reduction with carbon, the lead sulfide must first be converted into lead 2 oxide. Okay, lead 2 oxide has the formula PbO by roasting the ore. So, roasting the ore simply means we react it with oxygen. Now, this reaction with oxygen from the air also produces sulfur dioxide gas. So, what they're saying is lead sulfide must be converted into lead 2 oxide by roasting this ore, okay, with oxygen. So when this guy combines with oxygen, it produces lead oxide and sulfur dioxide gas, SO2. So they're asking us to do a number of things. So let's see what they're asking us to do. First of all, they're saying write a word equation for the roasting of lead sulfide. So a word equation is simple. What they're saying is lead sulfide plus oxygen produces lead 2 oxide and sulfur dioxide. This is the word equation. Lead sulfide, when it reacts with oxygen, it produces lead oxide or lead 2 oxide, whichever one you choose to call it, plus sulfur dioxide. This word equation was gotten from the statement that the question gave us. Let's go back to the question to check it out one more time for those who may be a bit confused. They said lead is found in the ore called Galena, and that ore contains lead sulfide, PbS, lead sulfide. So now they also said before reduction with carbon, the lead sulfide must first be converted into lead oxide by roasting the ore. So lead sulfide must be converted into lead oxide. How? By reacting it with oxygen. So when lead sulfide reacts with oxygen, it produces lead 2 oxide. And then they said this reaction with oxygen from the air also produces sulfur dioxide gas. So we write sulfur dioxide. So that is the word equation for the first question. Alright, so the second question says write a balanced symbol equation including state symbols for the reaction in part A. So before we write the symbolic equation with the state symbols, let's write out the word equation. The word equation says lead sulfide plus oxygen gives us lead 2 oxide plus sulfur dioxide. Alright, so let's write the formula for each and every one of them. Lead sulfide is PbS plus oxygen, that is O2, giving us lead 2 oxide. Lead 2 oxide is PbO, and then plus sulfur dioxide, that is SO2. Now let's balance this chemical equation. For lead, on the left hand side we have one atom, and on the right hand side we have one atom as well. So that means lead is perfectly balanced. For sulfur, on the left hand side we have one atom, and on the right hand side we have one atom as well. So sulfur is also balanced. For oxygen, however, we have two atoms of oxygen on the left, and on the right we have one atom over here and two atoms over here. So we would need to balance oxygen. How are we going to balance it? Having two atoms over here and having one atom over here and two atoms over here. Altogether we have three, and over here we have two atoms of oxygen. So now in order to balance the number of oxygen atoms that I have on both sides, I need to make sure that oxygen is equal on both sides. So we have 3 on the right and 2 on the left. So if I bring a coefficient of 3 here, I now have 6 atoms of oxygen on the left. So to make it equal, I'll put a coefficient of 2 here and put a coefficient of 2 here. That way, I now have 4 atoms of oxygen here and 2 atoms of oxygen over here. We're having 6 atoms of oxygen on both sides. That way, oxygen is now balanced. Now that oxygen is balanced, let's check out the other atoms to see. Lead on the left hand side is 1 atom. On the right hand side now it is 2. So to balance lead, I'll put a coefficient of 2 over here. So lead now is balanced as well as oxygen. How about sulfur? We have 2 atoms of sulfur because these 2 also affects the sulfur atom. And over here we also have 2 atoms of sulfur. So the equation is fully balanced. 2 PbS plus 3 O2 yielding 2 PbO plus 2 SO2. This is the balanced symbol equation. So let's include the state symbols. Lead sulfide is in the solid state. Oxygen is in the gaseous state. Lead oxide is in the solid state, and sulfur dioxide is in the gaseous state. This is the full balanced equation for the second question. And now the third question under this one says lead oxide is reduced by heating with carbon. Write a balanced symbol equation for this reduction, assuming carbon monoxide is produced. So we have lead oxide, which is PbO plus carbon, which is C. Now, before we know what to do with this reaction, we have 2 elements that are on the reactivity series. We have lead and we also have carbon. My question is, between carbon and lead, which one is stronger? So let's check our reactivity series chart and see. Now, if you watch with me, you see the position for lead, which is over here, and the position for carbon shows that carbon is way above lead. So carbon is more reactive and stronger than lead, which means carbon would displace lead from a compound during a chemical reaction. So we have lead oxide PbO reacting with carbon. So carbon comes over here to displace lead, meaning lead will have to leave. So therefore we have lead standing alone now plus carbon monoxide. This is the full equation. I trust you got value for this. If you did, please like, share, subscribe, and I'll see you in the next video.